Right, now let's move up to exercise 5 of the manual. And we have the propositional variables p1, p2, etc., p10. So 10 of these. And we want to determine, if possible, the valoration for each of the expressions. So the expressions are those that follow. So give me a second, let me just I like to organize my information on top like this. Okay, so the first one is, so for the formula phi, we need to find the valoration. So let me rephrase that. We want to find the valoration for each set of formulas, like this one, which I'm gonna define now, which satisfies the formula. So if you'll remember, satisfying a formula is saying that, let me just finish this real quick. P2 junction P3. So we have this expression, and we want to check if the valoration is we want to find a set of valorations for these variables that satisfy the formula phi. So what does satisfaction mean in this? It means it has to be equal to 1. So let me just try to find the exact slide where we spoke about this. It goes back here. No, it was before. These were the beginning ones. Ah, there they are. So satisfactory model and contradictory model. So we want to know if so we want to find a set, right, for each of those variables where when passed to the function phi results in a final value 1. So it's sort of like reverse engineering some output of this this formula. We want to we know the result that we want. We just don't know how to get it. So how do we do this? Right. Okay. So the standard way could be the one that we applied just prior, which is providing a truth table and doing it and trying to find if one of them results in 1. So let's say we got let me first just signal out that this is the data for the question, even though it's not very expression. Okay, so and we want to okay, so here we go. So let's do that. Okay, so let's begin. Let's provide the following table then. So P1, P2, P3, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, and 1, 1, 1. So let's begin. So the first one is easy, 0, 0, 0, 0. Then we got 0, 0, 0, 1. Oops, let me 0, 0, 0, 1. And then we got 0, 1, 1, 0. Then we have 0, 1, 1, 1, 1, 0, 0, 0. Let me just train my eyes a little bit for this. 1, 0, 0, 1, 1, 1, 1, 0. And for the last one, it's all ones. And then we go ahead and we cross-examine them like we did before. The result of this is 1. The result of this is 0. The result of both is 1. Again, 1. And then we do it. And then we do, whoops. Here is 1, here is 0. And both is 1. So actually, right out of the box, we've already found 2 combinations that result in 1. So this one is equal to 1, the valoration. So this one is also equal to 1, the valoration of phi. And the question just simply asks us to find 1. So let's stick to that and move on to the next question. Oh, here's a problem. Here's an issue. And I'm guessing this is where the question type wants us to trip over, which is the fact that we have, well, for this truth table we only had 3 variables, and that makes it 2 by 3 to the third is the length of it. So, and if we add more variables, see, we have it up to 10, we're gonna have 2 to the 10 the length of the truth table, which becomes unmanageable when performing calculations like this. So if we had a formula that were given to us with all of those variables, that would be tricky. However, from looking at the manual, we are never given, for some strange reason, we are never given yeah, so here's what I'm gonna do. I'm gonna paste them. We're gonna move on to the next one, because that one is already answered. and I'm going to simply solve them one by one. So continuing on with 5, we've solved the first one. Let's go on to the second one. And now, so we have phi equals to the negation of P1, which implies P2, in conjunction with P1 conjunction P2. So again, this is quite easy doing it the same way, so I'm just going to keep doing it the same way until a problem arises where I have to swap strategies, because this proved better than the tree method in speed terms. So we have P1 and P2. In this case, we only have 2 variables, so 1, 0, 1, 1, and so this goes like this: 0, 0, 0, 0, then 0, 1, 0, 1, 1, 0, 1, 0, then 1, 1, 1, 1. Okay, alright, so now this one is 1, although then we negate it and it becomes 0, and negated once more it becomes 0. And on the other side we have the conjunction between these two, which gives us a 0, and the conjunction between both gives us a 0. So on to the next one. So this one was not a satisfactory case, so not satisfactory. On to the next one. So this implies that's a 1. We negate that, we get a 0. Negate it again, we get a 1. Actually, I'm sorry. Did I make a mistake up here? Yeah, I did. I think I did. Yeah, because when we perform the implication, this part is negated, so this is 1. So given the input here, does negation precede? I'm gonna check this real quick. It actually makes sense that we perform this operation first, because well, if we negated this, then the result from this operation would change. I mean, I'm puzzled actually, come to think of. Does the negation occur on P1 first, or does the implication come first, or does it matter? I think it does matter. We get 1 here, this returns 0 after being negated, and if we did this we'd have 1 and the implication would give us 0, and then so we'd get 0 either way. Curious. I guess we'll find the answer for this one.